Right, kia ora everyone. Welcome to the mini lecture number 3. And in this lecture and for the next few of these mini online lectures, I'm going to be talking about the wonderful world of fungal endophytes, one of the most underrated groups of fungi in terms of their contribution to the global ecosystem. So stay tuned for this and the next few lectures and keep up with the content. As usual, I'm going to turn off my video and then we'll start the slideshow. Okay, so as I said, I'm going to talk about endophytes. And what does the name endophyte mean? So endo, of course, means inside, and phyte is plant, so phyta, or phyto is plant. And so again, just like mycorrhizae, the name says it all. These are fungi that live inside of plants. And just as for mycorrhizal associations, these are mutualistic relationships. And just as for the mycorrhizae, the major benefit that the fungus receives from the plant is carbohydrate. So again, the same applies. The fungus can't make its own sugars, and therefore it's reliant on getting those from the plant, which makes it from photosynthesis. What does the plant get in return? So it's a little different from what we saw from mycorrhizas in terms of the benefits that the fungi provide to the plants. In this case, the main benefit for endophytes is thought to be that it makes chemical compounds, and those chemical compounds provide protection of various sorts for the host plant. And those protections might be against pathogens, pests, and environmental challenges. And in this section on endophytes, we're going to look a little bit at some of the evidence for some of these potential protections. So for some of these mutualistic behaviors, I guess, of the fungi. So endophytes live within plants for most or all of their life cycle. So it's a little bit different to mycorrhizae, where part of the fungus is living outside in the soil and part of it's living in association with the plant. And endophytes typically, they're much more associated with the plant. Now, we typically think of endophytes as occupying the foliar or above ground parts of the plants, but many also colonize the roots and some only colonize the roots. However, they're different to the mycorrhizal associations. So with mycorrhizal associations, they tend to form these very specialized structures, either arbuscules or the sheath, the mantle that forms around the root tips. Whereas for endophytes, when they associate with roots, typically they're just living inside the root. And so endophytes in general just tend to grow within their host rather than form these very specialized kind of structural relationships that we see in mycorrhizae. A lot of different fungi form endophytic associations. And so most of the endophytes are Ascomycete and Basidiomycete fungi. And so in this way, I guess they're a little bit similar to the ectomycorrhizal fungi, which there's lots of ectomycorrhizal fungi across Ascomycetes and Basidiomycetes. But I would say that endophytes are even more diverse. So there's even a greater diversity of different kinds of fungi that form endophytic relationships compared to mycorrhizal. And another way that they differ from mycorrhizal associations is that the relationship is not always completely mutualistic. And in fact, what we're going to do when we look at these things in one of the later lectures is see that there's actually a continuum between endophytes that are fully mutualistic through to ones that are actually we could really consider as pathogens. And as for mycorrhizal associations, these associations, the endophytic associations, seem to be extremely old. And so they've found fossil endophytes that suggest the association is at least 400 million years old. So once again, these associations between fungi and plants is an ancient association, and therefore that's why they are so important, because they've been co-evolving together, plants and fungi, for hundreds of millions of years probably. Okay, so that was slide number 2. We're going on to slide number 3 now. And what I want to do is I want to just break down endophytes into 4 different classes. And there's various different systems of calling endophytes. This is not the only one, but I think it's probably the most useful one. And so I'll just go through briefly to introduce these 4 classes of endophytes. So the class 1 endophytes are otherwise known as the clavicipitaceous endophytes. And you can see why you might call those class 1. And some examples are fungi in the genus Claviceps and Epicloe. And we're going to look in particular at Epicloe endophytes in quite some detail in some of the following mini lectures. And these are endophytes that form associations specifically with grass, species of grass. And the endophytes that make up class 1 all come up from a single group of fungi, from a group within the Ascomycetes that are called the Hypocreales. Class 2 endophytes form associations with both the above and the below ground parts of plants, and they do this with a wide range of hosts. So there's lots and lots of different hosts that can form these associations, and furthermore there's lots and lots of different kinds of fungi that can form these associations. So these are very diverse. So these class 2 endophytes, in contrast to class 1 endophytes, can be found across the Ascomycota and across the Basidiomycota. In class 3, the difference between class 2 and class 3 is that class 3 only form associations with the foliar system, so the above ground part of the plants, or particularly it seems that these form associations with leaves and the leaves of trees. Now these are also extremely diverse, so you can find fungi from the Ascomycota and the Basidiomycota that form class 3 fungi. And the 4th class of endophyte is form associations only with the root system as far as we know. Now very little is known about these things, and they've got the cool name of dark septate endophytes. But some people think that these are maybe the most important endophytes actually. And so it's just that they're difficult to study, which is the reason why little is known about them. And so this 4 class of endophyte system is taken from this paper that's indicated at the bottom of the slide here. Okay, so what I want to do now is I'm going to look at examples of each of these classes of endophytes, except I'm not going to look at class 1 because we're going to deal with class 1 endophytes in quite some detail in coming mini lectures. So if we go to the next slide, that looks at examples of class 2 endophytes. And here's just some examples. And so, for example, on the left here, we have this fungal species called Fusarium culmorum. And this is shown with tomato, and it's showing a potential protective effect from drought. So if the tomato is inoculated with this fungus as an endophyte, then it is able to survive drought conditions, unlike ones that do not. And here's some pictures of that fungus here. But there's a huge variety of different endophytes that form class 2 associations. Some of them are very common fungi, such as Aspergillus, Penicillium, and Phoma. And so these are just examples of class 2 endophytes that have been isolated from a single plant species, and it just happens to be millet that's shown over here. And so you've probably heard of many of these genera, but lots and lots of different kinds of plants, so grasses, tomatoes, pretty much anything can form class 2 endophyte associations, and there's a huge range of different fungi that form these associations. Class 3, so these are the endophytes that form associations with leaves, typically of trees. And what I've got shown here is a phylogenetic tree. So this shows the relationships of the fungi that have been isolated from a single species of tree, and that's a loblolly pine for whatever it's worth. Now, you certainly don't need to know the details here. I'm not putting this up because you need to look and figure out what all these things are. The point that I'm trying to make here is that within a single species of tree, you get this massive diversity of all sorts of different kinds of fungi that are growing within the leaves of these trees. And it's in fact the blue and the yellow ones that are the ones that are found. The black ones are actually reference species. But if we box around the Ascomycetes in purple and the Basidiomycetes in green, this kind of hopefully illustrates the extent of the diversity, because these are 2 very diverged group of fungi, but there's multiple species of Ascomycetes and multiple species of Basidiomycetes that are found within leaves of the single pine tree. And this picture is generally true for all tree species. So if you go to any random tree, take its leaf, sterilize the surface, cut it open, and look at what fungi are present inside, you'll tend to find a huge diversity. And then the class 4 endophytes, these are these dark septate endophytes. Here's some pictures of the endophytes. So these are these dark guys, these little blobs here, actually the hyphae, believe it or not, that are growing inside plants that happen to be isolated from the Great Hungarian Plain for whatever reason. And the reason that you've kind of got these kind of strange pictures is that these things, most of them don't produce sexual or even asexual structures, so they're very hard to identify and very hard to look at and very hard to study, and they don't seem to grow in a free living way outside of the plant. So that's all I wanted to say about the endophytes in terms of dividing them up into the classes. And so you'll need to know what those different classes of endophytes are. What I'm going to do when I come back for, so that's the end of this mini lecture. What I'm going to do when I come back for the next one is I'm going to talk specifically about class 1 endophytes. And we're going to use the class 1 endophytes as a kind of an example group to understand some of the ideas behind endophyte relationships and the idea that they can be somewhere on a continuum between mutualist and pathogens. That's all for now, though. If you have any questions, please direct them to Piazza.